definite. All right, there we go. 4-3 is all about learning how to set up definite integrals. So you don't really have to integrate actually today. This is kind of just learning about the setup. So first of all, I need to give you just some general information about a definite integral. And again, I've mentioned this before, but everything we've done so far has been indefinite. Now you'll start to kind of understand why those were called indefinite and why these today are actually definite integrals. So I have my integral set up right here. And I'm going to label a couple things on this. That's why I left a little bit of room up there. But you'll see our integral symbol, the fancy looking S. And instead of just having that symbol by itself, now there's a little A down here at the bottom and a little B up there at the top. You still have your integrand, f of x, whatever that is. In this case, we're integrating with respect to x. But let me tell you more specifically about the A and the B. So first of all, the B is called the upper bound. And that is basically going to be the biggest value of x in your interval, or the biggest value of x that you're going to be integrating with. So that means the A down there at the bottom, that is going to be the lower bound. So again, that's kind of like your smaller x value. So we're integrating. Now when I read this out loud, obviously there's going to be numbers here for A and B. I'm going to pick 1 and 4 for just a second. So when I read this out loud, I would say the integral from 1 to 4, or whatever those numbers are, of f of x dx, whatever that function may be. You always kind of start with the lower bound when you read it, from this to that, and then there's your function that you are integrating. So the point today, I'm going to go ahead and give you the directions here. The point again is not to actually integrate, it's just to learn how to set up the integral. And we're still thinking about integration in terms of area. So it says, set up a definite integral that yields the area of the region. Set up a definite integral that yields the area of the region. Remember, when you integrate something, you're technically finding the area between that function and the x-axis when you integrate with respect to x. We're going to have a little bit today with respect to y as well. Now, each one of these are actually going to be given to you sort of as a graph, but the graphs here are pretty simple, so I'm going to give you a second to just kind of sketch this on your paper. You do want to put this function down because eventually that becomes the integrand. But then as far as what's happening over here, again, this is something that you can just put in your notes. The function is a horizontal line at 3. F of x equals 3. It's like y equals 3. It's a horizontal line at 3. But notice the area that I have here, colored in red, the area only goes from 1 to 4. Now, I didn't even plan that, you guys, but A and B here is what I used earlier for A and B. Smallest x value to biggest x value. We don't actually have to integrate, but let's just see what the integral would look like once we set it up. I'll give you a second to finish that graph if you don't have it yet. Again, it's just a horizontal line, but the area is cut off right here at 1 and 4. So here comes my integral symbol. And for a definite integral, the lower bound, again, is the smallest x value that you're going to be using. So this is a 1 here. Smallest x value on the left. Biggest x value over on the right is 4. And for the integrand, I'm just going to come back and use what they gave me up here. They'll always give you that part. So you don't have to put f of x equals 3. Just put the 3 down. And then dx versus dy, we will see a dy problem here in a second. But if they give this to you as f of x, then you should be integrating with respect to x. So always put the dx there, because when you integrate, you'd have to know what variable to use. So again, A, lower bound, and B is the upper bound. And this was all with respect to x. Okie doke. Not too bad. I want to do just a couple more of these. Again, it's going to be given to you as a function and a graph, but the graphs should be fairly simple if you want to copy this down. The function says f of x equals 4 minus x squared. And when I go to recopy this graph in my notes, here's kind of what I would do. I would put a point over here at -2, 0. Another point over here at +2, 0. A point at the top here where y is 4, and then you can just kind of fill in the parabola shape after that. If you get those 3 points done, then the rest of it is just an upside down parabola. Okie doke. Now the lines are not as clear as they were with that rectangle shape that we had on the last problem. But this one again, when you integrate with respect to x, the A and the B are the smallest and biggest x values on this graph. The smallest and biggest x values that you would be integrating. So I'm going to set this up as the integral from -2 to +2 of, now I've got a difference up there with that minus sign, so I probably should put the 4 minus x squared in parentheses, and then all of that would be integrated with respect to x. Later on, we'll figure out actually how to integrate something like that. Again, this is just kind of getting it set up. Okie doke. When you integrate with respect to x, you're looking at x values. Now, I want to try one more example like this, but not in terms of x. Now it's going to be in terms of y. So watch carefully here, because I sometimes like to throw something like this on a test or a quiz. Example 3, f of y equals y squared plus 1. Y squared plus 1. Now, as far as how to get this copied back into my notes, you've got a point right here at 1, 0. You could actually put another point right here at the origin. They're not really points on the graph necessarily. I'm just trying to kind of give you the outline of that area. You could put another point up here at 0, 2, and it all kind of comes together over here at 5, 2. If you wanted to put that on there. Again, that's just kind of helping you figure out how to sketch it back into your notes. But this is what we have to be careful about. The function is in terms of y. which means by the time I'm done setting up my integral, it needs to be with respect to y instead of with respect to x. So, if I was integrating with respect to x, I would probably use 0 and 5 because that looks like the smallest x and that looks like where the x is in. That would be the biggest x. But we're doing it with respect to y. So right here, the a on this integral actually needs to be the smallest y value, and that is a 0. So I am going to use 0 for a. But then the b is actually the biggest y value, not x value, biggest y value on this graph, which would be 2. The only mistake I see on stuff like this is, again, using x's instead of y's. If you integrate with respect to y, you're looking this way instead of that way. Now, the function itself can go right in there. Again, I probably would put parentheses around that just to keep it all together. So that's really the only thing you have to look out for. When you set it up, pay close attention to whether it's in terms of x or y. Okie doke. Any questions about those? All right, there's only, I think, a few more examples, but we're actually going to be finding the area now. We're kind of working backwards, actually, for the first part of this. Now it says, sketch the region. We'll have to do a little graphing here. Sketch the region and use a geometric formula. Sketch the region and use a geometric formula to find the area. When it says geometric formula, geometry, you're thinking like area of a rectangle, area of a triangle. May have to go back and kind of reuse some of those formulas that we've had in the past. So, first step, they'll give you this part, but the first step is to sketch the region. So I will have to kind of walk you through that, and if you don't have graph paper, that's perfectly fine. This, again, is just a sketch. But this integral is from 0 to 4. The function that we're integrating is just 2, and we're doing it with respect to x. So go ahead and sketch on your paper an xy coordinate plane. This is the first part of the directions. Sketch the region, then figure out what the area is. Now, I'm going to go ahead and label a little bit. 1, 2, 3, 4. 1, 2, 3, 4. I think we're pretty well just on the right side. So, the function is just 2. So, think about the graph of y equals 2 or f of x equals 2. It's just a horizontal line at 2 on the y-axis. That's what the function looks like. Now, the only part of the graph that we care about is from 0 to 4. We only care about this graph from 0 to 4. So here's what I would do. From this horizontal line, come straight down from where x is 0 and come straight down right here where x is 4. And again, you're always finding the area between the function and the x-axis. So I'm just going to fill this in real quick. It's this is a rectangle here. It's this that we're trying to find the area of. You get your function graphed first, And then you only pay attention to the x's that are on the interval. So going back to geometry for just a second, how do we find the area of a rectangle? We did this Friday. Length times width. So area equals, that almost looks like a minus sign. Messed my W up. Length times width. So looking at this rectangle, you really don't care which one's length, which one's width. I'm going to say the length is 1, 2, 3, 4 units. And the width, right here, you went up 2 right there. So 4 times 2 is 8. I'm going to say area of that region is 8 units squared. You have to set it up with the function, only looking between those x values, and then you should use something easy from earlier to actually get the area. All right, now they're not all going to be just rectangles, so let's try a couple more. Number 5, the integral from 0 to 2 of 2x plus 3 dx. 2x plus 3 dx. All right. Well, I know that's just a line. So as far as how to graph this, I mean, you could type that into your calculator if you wanted to get a better idea of what's going on. I may just try to wing it and see what happens. It's a line with a y-intercept of 3 and a slope of 2. So let me get a couple, or probably more than a couple, values labeled on my y-axis. Your graphs will probably look better because you have lines. So 2x plus 3, here's my y-intercept. Now I need a slope of 2. So I'm going to go up to right 1 to get to my next point. That would be at 1, 1, 2, 3, 4, 5. 1, 5 is the next point. Then I'll go up to right 1 again to get to my next point. Now keep in mind the interval. The interval only goes from 0 to 2. We're talking x's here. 0 to 2. So I don't even really have to do my rise over run anymore to get more points, because again, I only care about the x's from 0 to 2. This shape is a little bit different than last time. It's not exactly a rectangle. Part of it kind of comes to a point up here. So go back to your geometry days for a minute. Any idea how I could get the area of that whole figure? Say that again? Oh yeah, it kind of is. I don't know if I remember that formula though, area of a trapezoid. Any other ideas? Yeah? Yeah, that's another option if you don't remember any other formulas like me. I would just kind of cut that, and you could maybe do this a couple ways. I think this would probably be maybe the best bet. Put a little line right here. So the area of that whole figure is basically going to be the area of the triangle plus the area of a rectangle. You've got the triangle on top, rectangle on bottom. Now, area of a triangle, do you remember that? Yeah, 1/2 base times height. The rectangle, you guys told me that earlier, length times width. So let's start with the triangle. 1/2 base times height. Now, base for us kind of looks like this part right here. So the base, kind of using my x's, that would have a length of 2. And then height of the triangle, 1, 2, 3, 4. that would be my 1/2 base times height. Now the rectangle, a little bit easier over there. The length times width for that would be 2 times 3, or 3 times 2. So 1/2 of 8 is 4, 2 times 3 is 6. That would make 10 units squared for the area of the whole thing. Okie doke. I've got one more of these, and by the way, you really shouldn't need any other formulas today besides those. On every problem, you can either do a triangle or a rectangle or both to figure out what that area should be. All right, last one here, number 6. It's the integral from -4 to +4 of 4 minus the absolute value of x with respect to x. I don't have any of these with respect to y. I don't think you'll see any like that in the homework. Now, if you can't remember what absolute value looks like, I mean, absolute value is a v, so this one would just be flipped and then shifted up 4. If you can't remember all that, feel free to use a graphing calculator. I'm going to go 4 minus, to get absolute value, you want to go to the math button, write 1 to highlight num, and then absolute value should be your first option there. It might actually set up the bars, or it may just put ABS out front. Either way, we wanted 4 minus absolute value of x. Now, what was our lower bound and our upper bound? Yeah, -4 to +4. I don't care about anything happening over here. I don't care about anything happening over there. The only part of this graph that I care about is right there in the middle. So let me try to sketch that real quick on my graph. I need to go out to 4, out to 4, and up to 4. Boom, boom, boom. So that is my shape, just a big old triangle. So area for this, you could actually just do 1/2 base times height on that whole thing. 1/2 is there. Now the base, I'm gonna say, is the bottom part. So that should be 8 units on bottom. 1/2 base times height. Kind of have to look right here for the height. 1, 2, 3, 4. So 8 times 4 is 32. 1/2 of 32 would be 16. So 16 units squared. You could also kind of cut that into 2 triangles if you wanted to find the area. All right. Just getting used to definite integrals. That's the whole part of the lesson today. So here's the assignment. Should be C77 from page 312 to 313. Got 15 to 33 up here.